So today we're going to talk about solving literal equations. And equations and formulas, and a literal equation you might better know as a formula. They come in all different shapes and sizes and contain all different types of variables. So here are some that you might be familiar with. So I'm sure you've seen this before. P equals 2L plus 2W. Hopefully that's ringing a bell. That's the formula that you can use to find the perimeter of a rectangle, because a rectangle has two lengths and two widths. And if we add them all together, we get the perimeter. Another one that you should know is C equals 2 pi r. C equals 2 pi r. The C represents circumference, and circumference is the word we use to find the distance all the way around a circle. And of course, R represents the radius. Another one that you're probably familiar with, area equals length times width. So right back up to our rectangle here, instead of the perimeter, which is the distance all the way around, the area is how much space is being covered by the rectangle. So we multiply the length by the width. Another good one is one that maybe you have seen in science class, and it says this. So it says C equals 5/9 times F minus 32. This is a formula or a literal equation that allows us to convert from degrees Fahrenheit to degrees Celsius. So these are all formulas. And there's lots and lots more that you see in math and science classes. But sometimes it's necessary for us to transform a formula or literal equation. And if we're going to transform it, then we're going to use inverse operations in order to do that. So let's take a look at the circumference formula and think about this. If C equals 2 times pi times r, we're going to transform it to get the r all by itself. So let's think about the whole idea of inverse operations. So this is our strategy for this lesson, using inverse operations. So we're using inverse operations here, and if our given operation is multiplication, the inverse operation of multiplication is division. And notice that I've got the little yellow line through my equal sign. I'm still going to keep my equal signs lined up as we work down the page. So if we want the r by itself, we need to undo what has been done to the r. The r has been multiplied by 2 pi. Now, there's no goal here to simplify anything, so we don't need to plug in 3.14 or anything like that. We simply want the r by itself. So to do that, we're going to divide both sides by 2 pi. The 2's cancel, the pi's cancel, and we're left with r. And all we did here is use the division property of equality. And that is the inverse operation of multiplication. So what does r equal? R equals C divided by 2 pi. And that's our answer. So one of the things we're going to see as we go farther into algebra is that we're not always going to get a nice, tidy numerical answer. In this case, our answer is r in terms of C and pi. So we transformed the formula. So looking ahead, if 2x minus 3y equals 15, if this is the standard form of a linear equation, and Notice that root word of linear. The root word of linear is line. So this is the equation of a line. This is the standard form of a linear equation. What would the slope-intercept form be? So I've said that we're looking ahead, but I know that you all covered this in algebra or in pre-algebra class last year. So this is not a completely new skill. This is something that you definitely have done before. So if we have 2x minus 3y equals 15, if we want to put it in slope-intercept form, we need to solve for y. And when I ask you to solve for y, I'm asking you to get the y by itself. So we've got to undo everything that's been done to that y. And let's think about what has been done. That y has been multiplied by a negative 3, and it has a positive 2x added to it. So those are the two operations that we need to undo. So we're still using inverse operations, and the inverse of plus 2x is minus 2x. So we're going to subtract 2x from both sides. Subtraction, property of equality. 2x's cancel, and we're left with negative 3y equals, I'm lining up my equal signs, negative 2x plus 15. Lastly, remember we have negative 3 times y. The inverse operation for multiplication is division. So divide by negative 3, divide by negative 3, divide by negative 3. Every single term is getting divided by negative 3. That is the division property of equality, which undoes that multiplication. It cancels, and we get y equals, the equal signs are lined up, negative 2x divided by negative 3. A negative divided by a negative is a positive. So we get 2/3 x, and then 15 divided by negative 3 is negative 5. So we have put it in slope-intercept form. Hopefully that's looking familiar. Slope-intercept form, many of you probably know it as y equals mx plus b. So that is slope-intercept form, and we use it extensively in Algebra 1. So we solved for y in terms of x. We transformed the standard form to be slope-intercept form. Last two problems here, and we're going to do an error analysis here. So basically, I'm trying to find where's the mistake. So we're going to go through number one step at a time here, and we're going to find where the mistake is. So hopefully, maybe you've already caught it. So let's see. There's what's given. We're given 2m equals negative 6n plus 3. So if I am trying to solve for n, if I want to solve for n, look at what's been done to the n. The n has been multiplied by negative 6, and it has a positive 3 added to it. So if I want to solve for n, remember, anytime that we're solving, we're going in reverse order of operations. So we would want to undo the plus 3 first. If we're going to undo the plus 3, the inverse operation of plus 3 is minus 3. There is my mistake. So there is my mistake. So the inverse of addition is subtraction. So here is my mistake in this problem. I added 3 to both sides. So that's wrong. That's wrong. which of course is making the rest of it wrong. So let's take my clean sheet of paper here and let's do this correctly. So instead of adding 3 to both sides, I should be subtracting 3 from both sides, which will cancel with the plus 3. So now we have 2m minus 3 equals negative 6n. And now, what is the inverse operation of times negative 6? It is division by negative 6. Now, I'm showing you this again. You can write it by either saying all over negative 6, or you can write it negative or 2m over negative 6 as well as negative 3 over negative 6. But just remember that negative 6 is the common denominator for both of those terms. So it cancels. So here's our n. I'm trying to keep my equal signs lined up. So 2m minus 3 over negative 6. That is corrected. So once again, just a reminder, the inverse of addition is subtraction. So now, let's take a look at number 2 and see if you can find the error. So we're trying to solve for y, just like we did on the looking ahead problem. So we have 4x minus 6y equals 18. So if we want to solve for y, then we need to go in reverse order of operations, which means we first need to get rid of the 4x. That, of course, is a positive 4x. So in order to get rid of 4x, I need to subtract 4x. So that part is done correctly. So 4x minus 4x cancels, which leaves us with negative 6y equals negative 4x plus 18. Okay, and now we need to undo a times negative 6. So the inverse operation of multiplication is division by negative 6. So this step is done correctly. So we've got the 6's canceling to give us the y, and then negative 4 divided by negative, whoops, there's my problem. Here's my problem right here. We can't just cancel one time and call it a day. That's why it's probably your best idea when you divide both sides by negative 6. Take it upon yourself to show that you're dividing every single term by negative 6. So it won't just be negative 4x. It will be negative 4x over negative 6. And of course, 18 divided by negative 6 is where we're getting this negative 3 from. So not just negative 4x minus 3, but negative 4x over negative 6. So let's reduce this fraction and get our correct answer here. Negative 4 over negative 6 becomes positive. 4 over 6 becomes 2/3. 2/3 x minus 3. So there is the correct answer in the error analysis. That is solving literal equations.